Hello guys, I'm back for the new lesson for statistics and probability. And our topic for today is Central Limit Theorem. Statisticians are also interested in knowing the distribution of the means of the sample taken from a population. But before we discuss all this, let us know first the learning objectives. At the end of this lesson, learners are expected to illustrate central limit theorem, define sampling distribution of the sample mean using central limit theorem, and solves problem involving sampling distribution of the mean. Let us start with distribution of the sample means. This distribution obtained by using the means computed from a random sample of a specific size taken from a population. If the samples are randomly selected, the sample means will somewhat different from the population mean. The differences are caused by the sampling error. Sampling error is the difference between the sample measure and the corresponding population measure due to the fact that the sample is not a perfect representation of the sample. To further discuss, let's understand first the properties of the distribution of the sample means. And these are the properties. First, the mean of the sample means will be the same as the population. Next, the standard deviation of the sample means will be smaller than the standard deviation divided by the square root of the sample size. The standard deviation of the sample mean is called standard error of the mean. This is equal to the standard error of the mean. And this will be our formula. Whereas the standard error of the mean is equal to the population standard deviation divided by the square root of the sample size. Another property of the sampling distribution of the sample mean refers to the shape of the distribution and is explained by the central limit theorem. As the sample size n increases, the shape of the distribution of the sample means taken from a population with the sample mean and the standard deviation will approach a normal distribution. Distribution will have a mean and a standard deviation. The central limit theorem can be used to answer questions about sample means in the same manner that the normal distribution can be used to answer questions about individual values. There is a new formula to be used for the z values. And this will be our formula. So the z value is equal to the sample mean minus the mean divided by the standard deviation or the standard error of the mean. It is used to gain information when applying the central limit theorem about the sample mean when a variable is normally distributed or when the sample size is 30 or more. So take note of these important things to remember about central limit theorem. When the original variable is normally distributed, the distribution of the sample means will be normally distributed for any sample size n. Second is, when the distribution of the original variable departs from normality, a sample size of 30 or more is needed to use the normal distribution to approximate the distribution of the sample means. The larger the sample, the better the approximation will be. Let's apply this formula to a given problem. So this will be our first example. The mean serum cholesterol of a large population of an overweight adults is 220 mg per deciliter, and the standard deviation of 16.3 mg per deciliter. If the sample of 30 adults is selected, find the probability that the mean will be between 220 and 222 mg per deciliter. So let's solve for this one. So using the formula in central limit theorem, substitute all the given, we will have 222 minus 220 divided by 16.4 divided by square root of 30. Then, using your calculator, we can instantly solve for this and your answer will be 0.67. So, in order for us to know the percentage, we are going to use the z table. So, 0.67 will have an area of 0.2486. So the answer is the probability, which is 220 to 222, is 0.2486. Then multiplying it by 100%, we will have 24.86%. So this will be its probability. So let's have another example. The average age of accountants is 43 years with a standard deviation of 5 years. If an accounting firm employs 40 accountants, find the probability that the average age group is greater than 45.2 years old. So solving this using the Central Limit Theorem, since the participants are more than 30, so we will have z is equal to 45.2 minus 43 divided by 5 divided by square root of 40. Solving for z using your calculator, we will have 2.78. Since the equation concerns by more than or greater than 45.2, let's solve for the z table in the area. So we have 2.7 and 0.08. So it will become 0.4973. And this will be our area. Therefore, our answer is the probability that a given is greater than 45.2 is 0.5 minus 4.4973. Hence, the area has a z is equal to 2.78 is 0.4973. Therefore, the probability that the average group is greater than 45.2 years old is 0.0027, or multiplying it by 100%, we have 0.27%. And that will be our answer. So this will be our summary. We have learned about Central Limit Theorem, sampling distribution of the sample mean using Central Limit Theorem, and solves problem involving sampling distribution of the sample mean. So why not to try this problem on your own? Again, this is Miss Elise Iranjo for Statistics and Probability. Thank you for watching. Please like, subscribe, and share MATHerrific, learning materials for math and physics. See you around. Goodbye and God bless.